In this episode, Catbridge President Michael Pappas sits down with Ed Montalvo of the Montalvo Corporation, a longtime leader in web tension control technology. Together, they explore how the converting industry has evolved over the decades, from early mechanical systems and overheating brakes to today's highly refined machines. Drawing on decades of experience, Michael and Ed reflect on the fundamentals that shape the industry and discuss how modern technologies like load cells, automated positioning systems, and digital workflows are transforming how converters operate today. This is Converting Conversations, presented by Catbridge Machinery.
So good morning. We have a special guest with us today, Ed Montalvo from the Montalvo Corporation. Ed and I have been doing business for a long time. I'm trying to remember how long it's been, Ed, but I know I met you when I was in high school. So this is going back a couple years now. Do you remember, Ed?
Yeah, that was a couple of years after I graduated from high school, actually. The first time I saw you and Bill Christman was in Alan Shank's engineering office, and I believe you were kind of interns there, if I'm not mistaken. And I recall meeting both of you, talking to both of you at the time, sitting in Alan's office and going over some projects we were doing at that point with him. And Carl Stoffels was with us at the time as well.
Yeah.
So that's going back a ways.
Yeah.
So I don't know, but it was... what year did you start with Alan?
The drawings behind me are from the early 80s, so 1980. It's been a while. Time's flying, right?
Yeah, no kidding.
I want to share with everybody, how the industry's changed over the years and where it's going. When I first started, machines were really simple. A single motor drive, belts connecting things up, a basic brake. And when I remember Montalvo, we were so excited because we didn't have really good brakes. They were overheating. They were pretty limited. And that's just one element of what goes on in our industry and how everything kind of really changed. And I think Montalvo brought that concern for dealing with major issues. When you have a car and you have braking, it's one thing, but you can't get in your car and keep your foot on the brake and not expect them to overheat. And I think Montalvo early on saw that and brought a tool to our industry that was really important. And I think today what I want to share is how many really, really cool tools are out there and how exciting it is to be in these times. So before we go into the future, kind of give us a little background on that if you can, if you remember all that.
Yeah, I remember a lot of things. It's kind of an interesting story. The original patents on the dual disc multi-range brake, which is what the term was when we patented it originally, was my father's design. And he actually made the original prototypes of that in a basement machine shop in the home I grew up in Hackensack, New Jersey. That shop stayed there pretty much until we moved to Maine, and I made parts down there myself for the brakes. But it's interesting where the original design came from, because my dad told me this one time, and I just put it in my records so I wouldn't forget it. But he was a sales representative, manufacturer's representative himself, and he used to sell these large water-cooled clutches that were used primarily in the line drives on paper machines. And he would go into the paper mills, and he would see these as they're starting to run up the paper machine. He'd see these clutches go into action, and they would start, even though they were water-cooled, they would start to smoke. And the operators, he said to me, at that time, he said, whenever you go into a paper mill, there's always lots of water around, which, of course, we know that's true. And he said the operators would pick up a hose and they'd hose down the clutches when they were starting. And they were water-cooled clutches. Huh. But they'd hose them down because they got so hot. And my father said to me, I looked at that and I said, there has got to be a better way.
Yeah.
And so our first product was actually a clutch, not a brake. And we never did a single clutch, to my knowledge, on a paper machine drive, ever.
Wow.
But but it turned into a dual disc brake that was used in the unwinds. Pardon me, and in the paper mills, there's in lots of the paper mills, there's a converting room included, and the clutch, the brakes first started getting used in the converting rooms in the paper mills on winders and things of that nature, and they were using water-cooled brakes as well. And he decided that he wanted to see if he could attack that problem, because the same problem existed, except in a kind of a different form. The brakes that were used in the winders were all water-cooled brakes in those days, and there were a couple of top brands at the time, which we almost never see anymore. But what he found was that the cooling lines within the brake castings were getting filled up with all kinds of sediment, and that would cause them to overheat because there wasn't enough water getting through them. So he came up with the idea to let's put the cooling, even the water cooling, on the outside of the brake. And it actually began that way. And he had these little burner nozzles that he would put in between the discs, and it would impinge little bits of water on the disc just as it heated up. And it was a great idea, but it had the same flaw that the water-cooled brakes did. The nozzles would eventually clog up, and it didn't work anymore. So that was when he said, well, the answer to the problem is to size the brake right to begin with, and then you don't have that problem. Sure. And, over the years that came up, that ended up with the development of what he called the effective cooling speed, which you've seen in our materials. And since we instituted the effective cooling speed, we've never had an overheating problem.
Yeah.
So, that's kind of the history of where it came from. But it actually started as a clutch.
I think when I was young and an engineer, I didn't realize how much heat you need to dissipate. When we look at a paper machine, a typical, I'm thinking in a basic converting department for paper, it's 20 horsepower, 50 horsepower, 75 horsepower worth of heat that's continuously being generated. The energy that's going back into it has to dissipate somehow, and you just don't think about it. But really, that's what was going on. And back in the day, I do remember those water-cooled brakes because they were always like cleaning an old radiator filled with gook coming out of them. If you actually if the building got cold, they would crack and break, things like that. They'd freeze and break. So there was always complexities. And at the end of the day, they were very small. So they were never sized properly. And, that was just the way it was. And that's how it started. And I think for a lot of young listeners that are looking at this podcast today, they may not even understand the roots of what's happening. The tools that are out there today are refined nicely. So when you go to look at brakes, load cells, whatever we talk about here today, you'll see that it's been decades of refinement. You take the early on cooled brakes to the V-style brakes, so on and so forth. They've really, nobody remembers that past anymore because they're so refined for this industry and this space. So when I got into this space, Ed, I knew I wanted to be an engineer, but I didn't want to be an engineer that was stuck at a desk designing a bearing or something for 6 months. I wanted to be able to solve problems and meet people and handle some of the challenges to bring the industry forward. I think that's what's really exciting about being in converting. There's always challenges. How did you find the industry?
I might surprise you if I told you how I actually started out in college, so I'll go to what I switched to. All right. I transferred into the business program, so I am not an engineer. And I was thinking when Tanya asked that question, by the way, I was thinking about what caused me, what I would do differently, for instance, if I had the opportunity today to do that. Which when I hear that question, I often think to myself, what a stupid question. You don't ever get the opportunity, but it's a great thing to muse about. But I think that if I had the opportunity today to go back educationally, I probably would do something a little bit more toward the technical side. What's not generally known among our customers, I may have told you this in the past, Mike, but my brother was actually the heir apparent to the Montalvo Corporation, and I was headed down a completely different path, and I was actually, after my business education, I was actually a life insurance salesman. And, I'm one of those people that believes everything happens for a reason. So, and that life insurance training, the sales training, in fact, that came with it, is probably the best training that exists on the planet, because it teaches you how to deal with rejection, because lots of people say no when you say life insurance. So, but so I learned that very early on, and I've applied that many times. But my primary lesson from it is that nobody wants to be sold anything. People want to make a decision to buy something based on good data and good input. And when I moved back from Rochester, New York to Hackensack, New Jersey, my dad asked me. I was going to look for an agency in the Metro New York area to work at, and my dad said to me, "I'm starting up this manufacturing side of things, and maybe you could help me out for a couple of months." Well, that couple of months is 52 years now. So, and I'm wondering what I'm going to do when the 2 months end. But anyway, I've loved every bit of it, and I've learned a lot about engineering. And I often say to people, I never try to trick anybody into thinking I'm an engineer, because I'm not. But I often say, well, but I do play one at work sometimes. So, but the real heavy duty engineering I leave to the engineers, which is where it belongs. So, if I look back on it, though, I'd probably go for technical education, knowing what I know now.
I'm excited for some of the young folks that I see out there in the converting space. They're going to have tools that we didn't even imagine. I remember talking to Peter Lane at Intertech. They sell knives. Great vendor. They've been around forever. And there was a rumor that some German company was able to take score knives and automatically position them. And this rumor was, I think, in the 90s or something. And that just seems so far-fetched to me, that you could actually build something, get the electronics, and have some sort of a computer that could move all these. And now you do it in your sleep. We put knife positioners on machines every day. The tools that they're going to have and the amount of painful work that had to be done on a slitter to make changes or to operate or to monitor, so on and so forth, is so different. So when I feel like when they're getting into something, I'm starting to even see the next level, almost like an Amazon plant level, where AMRs are bringing material to the machine. The work order gets scanned. The machine has the setup. The operator does some basic things, but 90% or more of the machine is going to be set up with these automated tools. And their job is going to be to oversee either operating the machine, maintaining the machine, or managing the workflow going in and out of it. It's just so different. It's such a different view from, running a slitter, getting down on your knees and setting up the knives for an hour.
Yeah, but the training level of the people doing that has to go up rather dramatically as well. You're not talking about typical laborers as we did 40 or 50 years ago.
Yeah. I don't think it exists. We had one customer who statistically proved through their SAP system that with their assets that they own for a long time, they're not getting the same output. The machines are still there. They're still maintained well. The people aren't staying and interested in those jobs if they're just doing very difficult manual work. They're not going to invest their life into that. It feels like there's a big change in what people want to do. And all those aspects of the boring aspects of running the machine seem to be, in the rearview mirror.
And, in my business, there's a story my dad once told me when I first went to work for him. He said to me one time, he said, if you go into a typical converting room or factory and you ask the operator, in our business, you ask the operator, what is the tension you need? they kind of will look at you like, what are you talking about?
Yeah.
And when you explain it to them, they'll go over and they slap the web and say, that's what we need right there.
Yeah.
They didn't know the number, but they knew what it felt like.
Yeah.
And now they have to know both. And it wasn't very long after that, other companies that were in this before we were already dealing with that issue. But we jumped from just the tension brakes into the control systems, as you know, and our load cells, but going back to the beginning of our conversation, I remember brakes which were kind of cast iron weights hanging in a bag that was stretched over the unwind. And I remember brakes that were wooden, hard maple.
Remember the wooden
blocks.
ones?
Yeah.
Yeah.
Saw a lot of them.
Yeah.
And what's really surprised me was, we were all told that the Europeans were so technically advanced over us in all these things. But when I went to Europe the first time in 1977 to a Drupa exhibition, there were more of those there than I ever saw in the United States.
Really?
Yeah.
Yeah. Yeah, that's funny.
But, they did the job for what needed to be done at the time. But you can't run the speeds and the tensions you do today with such things.
Or the repeatability.
Yeah, of course.
Yeah. You remember the operator was almost an art form. They learned it. They learned how to, first, safety wasn't a major concern back then. People were touching the webs and getting really close to the machinery.
Yeah.
But it's definitely changed. But it hasn't. So one of the procedures we have here, any job we do, we set up a key products matrix and we go through the range of products that customers are trying to run on our machines. And we always see crazy values for tension, almost because they don't know. Yeah. They're still coming off of old machines. So they'll put in half a PLI to 6 PLI and you're like, nope, I don't think so. Not for 1 mil film. You already know that they just don't have a sense of what the actual value is. And that's, I'd say probably 10, 15 years ago, we started putting load cells in machines just everywhere. We buy Montalvo load cells, and we use them very effectively for so many reasons. But as this stuff comes in now, we're still seeing signs of that. I talked to somebody yesterday. They have an old slitter from, I'd say, the early 80s. And it's a little tough. They have no idea what they need for tension. And without all that data, we can't do anything here to cross-check. So what a lot of times we do is our lab line is nice. People can send us small samples. It's got load cells front and back, and we can check all the parameters that we need to verify and tapers, tensions, nip forces, all the things that go along with winding a good roll. And we do it on a 20-something inch width basis, so we can just bring it back, forth. But instrumenting a machine is super critical. Yeah. And you know where it also plays out at it is the load cells on center winders to us are critical for 2 reasons. A, consistency. Cam lock shafts, differentials are beautiful, but they also need maintenance about once every 6 weeks. The coefficient of friction changes a little bit every day, and then they need to be re-oiled.
Yep.
We have these load cells on the upper and lower rewinds now, just so we can monitor, control tension with the load cell, but also look at our scale factor. And as that scale factor starts to slide and our trim range starts to slide, we pop up a message saying it's time to re-oil. There's maintenance required. And it's super important. If we didn't have those load cells in there, customers would go a year or two and then have a lot of bad material going out the door, wondering why they're doing reworks, so on and so forth. But think of how effective that seems obvious to us tool is now that we didn't have back in the day.
Yeah. Well, you've taken a major chunk out of the waste material or the rework of material, which is, when I got in the industry, people didn't even think about that. It's a bad roll, you just stick it off to the side and deal with it later. Yeah. And a lot of times dealing with it just meant sending it to a recycler. But today, we don't really have the option to do that anymore. Yeah. You got to get as close to 100% out of a parent roll that you bring in as you can get. Otherwise, you're losing money.
Yeah, absolutely. And I think people had the good operator, and well, he could run this job, and you had the typical operator, and they could run the other jobs. So all that kind of stuff is taken away. It's a little bit like a GPS, right? Now nobody looks at a map. Nobody has to look at landmarks and know where they're going. It's good and it's bad. Fundamentals are really important to learn, but at the end of the day, you got to get material out. So it's not everybody needs to know all that. With a good instrument machine, it's almost like follow the GPS, trust it. Somebody else could be the map maker.
It's very interesting you say that because, when you get a little older, young fella, when you get a little older, you start doing things like, I'm not going to use the GPS except to tell where the best route is in case there's heavy traffic, so I can avoid the heavy traffic and then shut it off and go the other route. But there's a practical analogy in our business. You need to know the basics of things. Yeah. You can't let the technology do everything for you. You have to understand how it works. If you don't, you're going to get in trouble somewhere down the line, and it's going to cost.
Yeah.
So, I assume you guys are doing business in the composites market, correct? Mm-hmm. Well, when we first got into doing tension control systems for composites, I'm sure you saw this. The companies that were developing this material, they were kind of scientists, mm-hmm. And it always amazes me that they attempted to develop converting machines without looking at converting machines. And the first one I worked on, they were saying that it was a company was saying that they were making pressure vessels and they wanted to improve their tension control. And I said, well, what speed are you running? And they said, what are you talking about? I said, how many feet per minute are you running as you wind these pressure vessels? And the guy looked at me kind of perplexed and he goes, oh, we move about 17 inches a minute. They had no concept of what was involved in making it run quicker.
Yeah. It really hasn't changed today. Do you see that? I see that with the battery separator material. It's super thin. The tensions have to be extremely low. People say that zero tension. I'm like, well, you have zero chance of winding a roll at zero tension. There is a tension. It's just low. And without instrumentation and having all that, you're going to run into problems.
Yeah. Yeah, well, the composites industry is running faster.
Yeah.
But not a whole lot faster.
Oh.
So, some of them are, but generally speaking, it's got to, when you consider the potential market for this just in energy savings,
right,
they have to make it much faster than they're doing it even today.
I think that holds true in battery.
Yeah, no question about it. It's
super thin, there's length, and it is booming. People are building factories all over the United States and everywhere to run some of these materials. And, we're running them at a couple thousand feet a minute right now. And it's exciting. The machines that we have with the right instrumentation just sit there and purr every day. It's nothing like the old slitters with the guy tapping web. It's really the right setup. That's important.
It's funny, having a marketing education, when my dad asked me finally to join the company past the 2 months, I decided I'd do a little market research to see what the potential market was. That seemed to me the thing that you do if you've been in business school, right? And so I did a little research on just the North American market. It was the only place we were selling at the time. So at that time, there were, if I recall correctly, we're going back a long time now, but if I recall correctly, there were something around 1,000 paper mills in North America. And 700 of them, roughly, had converting capability of some type. And the others were just making parent rolls and shipping them out to converters. But so those 700 or so, that we considered that to be our market. But what was interesting to me at that time, when you compare it today, if you're just talking paper, it probably applies to every other material there is at some level. But at that time, we were producing paper in this country. The highest speed was about 2,500 feet a minute. I've personally stood in front of a machine, not in this country, but I've stood in front of a machine running paper at 7,000 feet a minute. And, the dynamics of everything changes when you run this. I mean, you can't even run the speed to that level without changing the dynamics. So, everything has changed.
Yeah.
The operator who could run back and forth from one end of the machine to the other to check and see how things are going, you can't do that anymore. It's moving too fast.
Yeah.
So the automation had to take place.
I wanted to tell you how we bridge people from the fundamentals into applying these tools. And we, in our lab, we have a 20-inch wide lab. And it has lots of different configurations. So if I just start at the unwind, for example, you bring a new person in off the street, whether it's a technician, an engineer, a salesperson, you kind of have to teach them our vocabulary and how to get around the machine and what all this stuff means and how to get all the fundamentals dialed in right. So we have over 60 chapters with tests and labs and information on all sorts of fundamentals so that we can quickly get new employees speaking our language. And I'll give you the unwind, for example, because it kind of applies to lots of different ways that people handle unwinds. So when they come in here, we teach them about the basics, meaning torque, tension, so on and so forth, build-up ratios, web width changes, go through the different materials and what tensions you'd be running them, looking at, solving the min-max ranges for different, a slitter put in a department for different product groups that get pushed through there. But we also have it with a load cell, so we can add the load cell control. We have a diameter sensor, so we can teach them what levels they need, and even salespeople. Is it okay to have a machine without any tension control? No. Why? Look at the load cell. The tension's going up as the roll goes down. Okay, let's add a diameter sensor on there. Let's do it basic-wise. Well, that's great. If the machine's running at a reasonable clip, and that zone isn't too fussy with tension range variation, which most aren't. Diameter sensor does a good job for a steady state machine. Now let's add the load cell into the loop and adjust the tension. So you can adjust the tension, and on the PID loop through our screens, you can see all that. And you can see on the oscilloscope as you're accelerating and decelerating the changes. You can see the windage factors and some of those things. And then we also have a dancer on this machine. So in a day or two, we can teach them all different ways to look at the unwind and start there. And I think it's really important, to know where the fundamentals are. So when we start talking about PLI and we start talking about different things on machines, it all kind of makes sense because you've nearly touched, felt, and seen it from all the different perspectives of how it could be handled. And I think it's super important that if you're a new person coming into this industry, you try to appreciate all the different levels. Some people come to us and they're like, well, any unwind should be done this way. Not necessarily. There's a lot of ways to handle these things. If you really understood what you were designing, developing, or using, you would see that there's a lot of good ways to solve problems, and they're all perfectly fine if they're controlling tension within the range that's appropriate.
You kind of nail home something I said earlier, which is, the educational level or the training level of the average employee today working at the side of a machine is so much higher than it was 40 or 50 years ago, even 20 years ago.
Yeah.
And it kind of really pleases me to a degree to be able to make the argument to other people that I talk to on a regular basis that, automation doesn't necessarily, in fact, doesn't eliminate people. It raises people up to a higher level.
Yeah.
And that's what we need in our society.
Yeah.
I'm all about the team, by the way.
I get it.
It's really important to me. So
I told a story at our Christmas party because I heard it from the CEO of John Deere in New York City. He was doing a presentation, and I don't have the exact numbers, but he talked about in the 1800s what percentage of our population had to farm, put a shovel in their hand and went out there and farmed the land so that people could eat. And it was something like 58% or somewhere in that range. And today it's like 3. What's different? You got this tractor that could do miles and miles of farming. It's the best tool you could put in that farmer's hands to get the job done. And when we look at, the tools that we're putting out in our industry, I think, we're heading in that direction. We weren't as quick as the farming industry to build up tractors with that much potential. But in our slitting industry, I see it happening, and I see it happening now. We're combining all these pieces that we've had put together over the last decade, putting them into slitters and getting powerful results. We just finished up with a customer, and they're getting 4-to-1 off of their slitter. So 4 old slitters to 1 new one. And whatever it wasn't one particular thing that solved the problem. Much quicker setups. They can't even run fast. They have to inspect the entire time. So there was no benefit in going faster. But easier unloading, quick changeover, perfect ergonomics, new integrated safety, so they were no near the machine anymore. Those are really exciting. And I feel like we're bringing ourselves in this industry up to like the farming industry. And so
that's interesting.
It really is. So I like bettering people as well. At Catbridge, we used to have bridge ports and milling, basic milling machines, and who does that anymore? We're making parts at crazy rates now. You don't have time to pull a handle down and turn a crank. So.
Well, I would tell you that we still have an old Bridgeport on the floor here.
Yeah.
That when we need to make a one-off, it gets used. But but generally speaking, you don't see it running very much. So.
Right.
But the funny thing is, the guys that are for us in a machine shop level, the guys that are working out there and the women that are working out there, they have to know. They have to know how to do the machining, but they also have to know how to program the machine and make the machine do what they want. So that's a cut above what we were 10, 15 years ago. So
we are trying something new here. We do so much programming between taking the parts from SolidWorks, putting them into Mastercam, getting them out to the machine, doing dozens of parts a day with lots of little jobs. Nothing here is 100 of anything. You might get a night position or you're making carriages and you get a good quantity, but almost every work order is 1 part, 2 parts, really low. So we're integrating an AI tool that'll automatically do the programming. So something that would take us 30 minutes to program is like 1.5 minutes. So we have 4 identical machines here. So all identical tooling and everything else. So it's made that function much easier with a lot less mistakes. Like same thing as converting. You had the guy who really knew how to do the complicated one, but you also had the guy who programmed really fast who made mistakes. A lot of that stuff's going away. And as it gets pulled through the machine building world, you're going to see a lot of that on slitters as well, and other things within the converting space. So, yeah, I'll share with you where this is all in its first year out type stuff. So we're starting to see it does a good job. It does about 80% of our work, and we check it, but we're just really getting our feet wet. I'll give you some good feedback as time goes on. But I kind of get the sense that these setup assists in our machines and these coordinated discussions, connections between the ERP systems are going to be fascinating, even down to the packaging level. That's the hardest thing is we start pushing it out faster. We got to pack it faster. And so we're working very closely with some strategic partners on that as well, and doing some of that stuff ourselves to just make sure we didn't just push it down to a new bottleneck.
Well, you guys are the ones that introduced us to SolidWorks, by the way. I don't know whether you knew that or not, but
oh no,
I was in your shop one time just making a casual visit as I was in the area, and you showed me on your personal computer on your desktop, you showed me a complete machine all laid out in 3D.
Yeah.
And I said to you, what software do you use? And you said SolidWorks. And I came back here and I said, you guys check out SolidWorks. That's pretty amazing. So
that's awesome.
That's a long time ago. But,
sure.
Yeah. It was you that recommended it. So
it's nice to lay out an entire system, kind of share some of that with the customer. We have a pretty complex slitter going up right now. 1-inch cores, 1/2 inch wide, bowl feeders, sorters. We're running really high cycle rates. We have to get them all on there. To build a digital version of it first and have the teams kind of looking at it and poking at it from every direction is such a big help compared to building it and then going, I wish we saw something earlier. Now you see it on the digital side.
Yeah. Just from the viewpoint of incorrect tolerances.
Yeah.
Those are pretty much gone.
Yeah. Right.
So,
yeah.
But when you talk about an entire system where you can visually inspect it before you build a single part, that's, even to me, that's sort of Star Trek stuff,
And the beautiful thing too, I think the digital, building it digitally, pushing it from one piece of software to the other eliminates fat fingering mistakes and, translational mistakes. We use an outside service, I'm talking 10 years ago, and some holes weren't in the right pattern. I'm like, how is that possible? Because around here, if there's a mistake, the engineer did it because it's digital all the way down to the machine tool, right?
Yeah.
It turns out they're still spinning handles in the shop that they had to use to make this one beam for us. We hardly send stuff out, but it reminded me of the mistakes that used to be made back in the day. And a lot of that you think about in our world, somebody put the wrong tension in. Oops, they didn't put a taper in there. Oh, they didn't set the core right. All those little things. And at some point, people used to say, no, there's too much in the slitter. Well, the operator had too much freedom back in the day to make mistakes too. So once you build up that quick recipe or profile for that product, you can pull it back up, use it, and run it and make really good rolls without mistakes. And so as it applies to what we do every day back here or our customers do on our machines, it's the same sort of scenario where once you build the product profile, you pull it up, the personality is there, you already know the tensions and the tapers and all that kind of stuff.
Yeah, and a downline advantage to that too is that every one of your operators at some level becomes a quality manager.
Absolutely.
So
yeah.
I realize I just dated myself by using that Star Trek analogy. I probably should have. Anyway.
Yeah. It's kind of nice to sit back and kind of remember where we came from and the whole converting experience.
Well, you know what they say, if you don't remember where you came from, you're likely to go there again. So.
I love it. So thank you for listening to Converting Conversations today. I'm Michael Pappas. Watch or listen on our website, like or subscribe on YouTube, or find us wherever you get your favorite podcasts. Thanks for listening to Converting Conversations with Catbridge.